Hello to all. Myself, Arvind, representing the team MilliVolt. Today, I'm going to be explaining the PPT with further details. So, the problem statement that we have taken is 1299. It is a problem statement based on the unit of power, which the problem statement is developing an AI-powered energy management system for industrial and commercial facilities to optimize energy consumption. So, this is a solution to the problem statement. We are going to be developing an AI-powered energy management system for industrial and commercial facilities to monitor, control, and conserve energy consumption of the industries. We are going to be first connecting real-time data with the sensors, which is already fixed in existing wiring of the systems. The input microprocessors will send the collected real-time data to the database via Wi-Fi. ML models are integrated into clouds, which take data from the database and then format it, use the output, and sources in a carcass. We are developing a user-friendly interface for monitoring, controlling, and showing the recommendations from our ML models to conserve energy consumption. All the data that is being collected from the sensors will be stored for energy audit and further use of this data. With intelligent simple events, what we are going to do, we are going to be first connecting data from the industries with sensors in real time, like the voltage, current, power factor, apparent power, wear power, and etc. to know the energy consumption of the industry in real time. The microprocessors will send the connected data through the internet to a database we stored in the cloud. The ML models are already integrated into the cloud, which take the data from the database and then format it. The interface, which is an app and a website dashboard, takes the data from the database also. The interface shows the current usage of energy consumption, AI prediction, and ML models prediction on energy consumption and energy conservation suggestions, and also corrections of power factor. It also shows us the various uses of electricity, like for example, if a factory is having solar energy or wind energy, or they are storing it in some sort of UPS or batteries, we can monitor all those things and then calculate and how much energy is consumed, which factors of energy provided solution. So this is the flowchart on how we are going to make it. So here is solar EV source generator, which is a regenerator, and as a storage layers. We are going to be monitoring all the real-time data on this, and we are going to be auditing, and we are also going to monitor real-time consumption of data. We are going to be doing this with the NI in the models, non-intrusive load management system. What the advantage is using the system is we don't need to fix individual sensors for individual emissions. We can monitor each individual emission at one particular point. This reduces the cost of our product. We are going to be collecting the real-time data and sending it to a microcontroller. The microcontroller is going to send it to the cloud. The cloud will send the data to machine learning models, suggestion models, user interface, and also control of appliances, which is also integrated into a user interface. User interface can control HVAC appliances based on the user's conditions or preset time when the machine can turn on or turn off. Here is a use case diagram on how we are going to show our users what they are going to do. So the first, there are two sets of people that we are dividing it: the high question job or the employees. So what we are going to be doing is restricting some use cases for the employees so that they cannot control the energy grid of a factory. So we are going to be having a login, live data monitoring, control of HVAC appliances, alerts on any sorts of malfunctions in the electrical grid, smart calculations for energy saving, and smart recommendations from ML models. In live data monitoring, we are going to be doing all electrical parameters like voltage, current, as I already told, using the NIM model. We are also going to monitor the air quality in industries, control of HVAC appliances, as I already told. We can do it in a scheduled time period or manual based upon the instance condition. Alerts on power cuts or shutdowns. We will be showing the users on when there's going to be a power cut in the area, And also, if there is any sort of short circuits, low voltage or high voltage, or any form of thing that can damage machines, we will showing it alerts, sir. Calculations on renewable the energy, and also the amount of energy that can be saved machine by renewable energy sources. Smart automations, it shows the peak time energy consumption. Like we all know that when the industries consume more amount of energy in peak time, there will be more amount of electricity we have to pay. So we also analyze the period and recommend the industries on that also. We also do complete analysis on power factor of the industries to reduce the amount of electricity that they are paid. Here is the showstoppers of our products. We use NILM models to identify what component is using how much amount of electricity instead of using individual sensors. This reduces the total product cost. And we also do solar, wind energy, or diesel generator, EV source. All these can be monitored in one product. It eliminates the more number of products which is integrated into the system. Electrical parameters storing for energy audits. All data has to be stored for future references and for energy audits. So we do that in our database. Next, a user-friendly interface is mandatory so that the users can easily understand their electrical power consumption and reduce their consumption based upon their needs. ML models for analyzing energy shift patterns. We use integrated ML models already integrated into cloud. So this reduces the hardware usage since it is already running into a cloud. Business model. What we have planned to do is manufacturing and supplying large amount of electrical smart meters for the electrical grid system so that the upcoming electrical meters can be digital or smart energy meters. So this is the main target so that we can get more number of customers over the segment. We are going to be collecting money from the consumers in two methods. One is the product based and the service based. Product based, which pays for the product itself and the installation fees. Next, the service based. The users have to pay certain amount to use our product and get benefited from our product. The collected amount from the service based will be used for the interface development and the price we have to pay for storing data in clouds. So here you can see a demo interface which we have developed right now. And we have visited 3 commercial buildings and 1 industry visit on how they are managing their electrical consumption. Next, this is our POC, our first week prototype, and this is our 2 model right now. Over in the bottom, we have given our YouTube channel link, which has videos on our prototypes and working models. We have also added a guide link in which you can see the technical data and technical specification on how we are doing this fix. This is our team. We have 2 mentors for helping us to bring this product into a reality. Thank you. Signing off, Arul.